This lecture covered the testing a graph for symmetry with respect to an axis and the origin. We're also going to learn how to find the points of intersection of two graphs. Now, knowing the symmetry of a graph before attempting to sketch it is useful because you need only half as many points to sketch the graph. The three types of symmetry can be used to help sketch the graphs of equation. First, a graph is a symmetric with respect to the y-axis if whenever x and y is a point on a graph, then negative x and y is also a point on the graph. So this means that the portion of the graph to the left of the y-axis is a mirror image of the portion to the right of the y-axis. And we can see the graph. So on the left side, we have negative x and y. On the right, we have x and y. So this will be symmetry. Now, the second, if we have a graph, or we say a graph is a symmetric with respect to the x-axis, if whenever x and y is a point on the graph, then also x and negative y is also a point on the graph. Now, this means that the portion of the graph below the x-axis is a mirror image of the portion above the x-axis. So we can see above the x-axis, we have s and y, and then below the x-axis, x and negative y. So this means the graph is again symmetric with respect to the x-axis. Also, a graph is also a symmetric, this time with respect to the origin. If whenever x and y is a point on the graph, then negative x and negative y is also a point on the graph. So this means that the graph is unchanged by a rotation of 180 degrees above the origin. And we can see on the graph. So this is respect to the origin. The graph is a symmetric with respect to the origin. And so to the left, we have negative x and negative y. Above x on the right, we have x and y. So how do we test for symmetry? The first, we said the graph of an equation in x and y is symmetric with respect to the y-axis. When replacing x by negative x, we yield an equivalent equation. Also, the graph of an equation in x and y is symmetric with respect to the x-axis. This is when we are replacing y by negative y, it will yield an equivalent equation. So the graph of an equation in x and y is also symmetric with respect to the origin when we are replacing x by negative x and also y by negative y. And that will yield an equivalent equation. So let's see an example. Here we say that a graph of a polynomial has a symmetry with respect to the y-axis when each term has an even exponent or is a constant. So for instance, the graph y equal to 2x to the power 4 minus x squared plus 2 will have a symmetry with respect to the y-axis. And also similarly, the graph of a polynomial has a symmetric with respect to the origin when each term has an odd exponent. So let's test the graph of y equal to 2x cubed minus s for symmetry with respect to first the y-axis and then b, the origin. So this would be a good example for us to get a concept. So first we write the original equation y equal to 2x cubed minus x. Then we say y equal to, we replace x with negative s cubed and also x here negative x. So after we finish, we get negative s cubed plus x. So we can see that 2s cubed minus x is not the same as negative 2s cubed plus x. They are different. So this means the result is not an equivalent equation. Now, so here we say because replacing the x by negative x does not yield an equivalent equation, we can conclude that the graph of y equal to 2x cubed minus x is not symmetric with respect to the y-axis. Now, let's try the second option, which is this is with the origin point. So y equal to 2x cubed minus x. So with the origin, it means we have to replace x by negative x, and also we have to replace y by negative y. So we get negative y equal to 2, negative x cubed minus x now is negative x. Simplify this equation, we have negative x cubed plus x. Then we are going to multiply the whole equation by negative 1. So we get 2x cubed minus x, which is the same as original equation 2x cubed minus x. So here we have, again, equivalent equation. Now let's see another. Because replacing x by negative x and also y by negative y, it will yield us an equivalent equation. So here we can conclude that, again, the graph of y equal to 2x cubed minus x is symmetric with respect to the origin, as we can see in the diagram when we plot it. So at the origin point, we have the symmetric of it. Now, a point of intersection of a graphs of two equations is the point that satisfies both equations. So now we can find the points of intersection of two graphs by solving their equations simultaneously. So for example, find all points of intersection of the graph x squared minus y equal to 3, and also x minus y equal to y, 1. So here, we begin by sketching the graphs of both equations in the same rectangle coordinate system. We know x minus y equal to 1 will give us a linear equation. And since x here is square, that gives us the parabola. So we can see the intersection of the linear equation and parabola. So we have -1, -2, and 2 and 1. So here we say from the figure, it appears that the graph have 2 points of intersection. And you can find these 2 points as following. So we have the 2 points here. So the equation again is convert to y equal to s squared minus 3 by solving for y. S squared minus y equal to 3. So minus y will give us 3 minus s squared. And y will give us, again, s squared minus 3. Then from here, we have the second, solve the second equation for y. The second equation is x minus y equal to 1. So minus y will give us 1 minus x, which means y will give us x minus 1. So we have x minus 1. Then we can equate the y values. So what we did is that we have y equal to y, so s squared minus 3 equal to s minus y, 1. Then in this case, we have the equation s squared minus x minus 2 equal to 0. And we can solve for the value of x. So we have x minus 2 times s plus 1. So s will give us +2 or -1. So you can see our point, x is -1 here and +2. And that's what we get here. So next, the corresponding values of y are obtained by substituting x equal to 2 and s equal to -1 into either of the original equations. So we all know y equal to s squared minus 3. So if we know the s value, we just substitute and find y. And that's what we did. We get 2 and 1, and then -4 and -2. So that will be the conclusion of these lectures. Again, these lectures, we learn the basic concept of, again, the intersections, and also testing a graph for symmetric with respect to an axis and origin. So again, see you in the next lectures.